To double check I'm correct to use 0, we can also read this red text. It says PLC register 43011. We don't know where this 43011 comes from either, but if you explore a little bit, you can see that there is a table that tells you a Modbus protocol divides coils and register to 4 parts, and the last part is from 40,001 to 49,999, and you can see this is the address range of holding registers. Now we can confidently guess the manufacturer is storing the temperature data in the first holding register, which is also 40,001, which means the start address should just be 0, because if we want to read the first register, we should start from 0, right? Okay, now we have one more parameter to fill. That is the count. The doc says the count is the number of coils to read, and there is another information I want to give you. You need to know each register is 1 word, is 16 bits, is 2 bytes. These are the same length in computer science. So we need to know how many registers the manufacturer uses to store the temperature information. Back to our datasheet, in these green cells it says number of coils to read, high byte is 00, number of coils to read, low byte is 01. So we combine these 2 bytes, which gives 0001 in hexadecimal, which is also 1 in decimal, and the red text also says PLC register 40,001, which means the sensor is storing temperature data using only 1 register or 1 coil. We can also double check this is true by observing those yellow cells. This is an example response from the manufacturer. These cells are 01 and 04, and they are supposed to be the values of temperature high byte and values of temperature low byte. Remember I told you before that each register is a word, which is also 2 bytes. These 2 yellow cells are 2 bytes, which means 1 word or 1 register, which also means we only need to read 1 register from the start address. Now we can confidently fill in the last parameter 1 to the count argument. So let's try to call this read holding register function in Python, and we read the register values with rr.registers. You can see that it returns an array with only 1 value, 343. Is this what we want? We don't know. We read the datasheet and it says the return value should be 01, 03, 02, 01, 64, B8, 3/2. But we only got 1 array with 1 integer back. What the heck is this? And we also don't know if we have sent the correct command to the sensor when we call that read holding register function just now. Now it's time to use our secret weapon, logging. Remember we commented out the logging code at the beginning. Now we are going to add them back and see what is going on under the hood. Now let's rerun the program we wrote. Look, there's more logging information we can expect. You see that send 0x1, 0x3, 0x0, 0x0, 0x1, 0x84, 0xa, that looks exactly the same as our datasheet, which means we are sending the correct command to the sensor. The last 2 bytes are 0x84 and 0x0a. They are actually computed automatically by the CRC checksum algorithm. So even if we never manually wrote them to our code, we did send them to the sensor. And we can also see this receive 0x1, 3, 2, 0, F3, F8, 1 is the information we got from the sensor. If we compare this to the datasheet, the first 3 bytes are the same, 1, 3, 2. From the 4th byte, 0x0, 0x3, they are different from our datasheet. If we look at the description, we can understand why they are different. Because these 2 bytes are the actual temperature value we get from the sensor, and of course, because those first 5 bytes are different from the datasheet, the CRC checksum is also different. One thing we can be sure is we did get the temperature value from the sensor now. But how do we read it? Is 0x0, 0x3? What the heck is this? How do we convert this to Celsius degree? Well, we don't know. Let's go back to our datasheet to find more clues. In the datasheet, there's another calculation. It says temperature value equals 0x0164 to decimal is 356. Real temperature is 356 divided by 10 equals 35.6 Celsius degree. Okay, this is something. This 0x0164 isn't a decimal number we usually use. It's appended by a 0x. There comes our second tip I want to teach you. Numbers starting with 0x means hexadecimal. So it's actually not a decimal number, but a hexadecimal. So we need to convert this hexadecimal to decimal, but how? Easy. If you write it in Python, it will be converted to decimal automatically. Let's see 0x0164, it returns 356, the same as the document. Now something clicks in your head, right? Let's go back to our 0x, 0xf3 and combine them together in Python. We get 0x00f3, it returns 243. And there is our accurate temperature mode here. It shows the current temperature in my room is 25 Celsius degrees. And we divide this 243 by 10, we get 24.3 what? Celsius degrees. You can now pause the video and take a cup of coffee. In the meantime, think about what we have done for a moment. It's not that hard, right? You can successfully read the positive temperature data now. And it's through Modbus RTU in these RS485 ports using the Chipsee panel PC. But before we go out to have another cup of coffee, there is another piece of information on this datasheet. Well, it says temperature value is signed data, hexadecimal. Negative values is in two's complete form. For example, temperature value equals 0x58 to decimal equals negative 168. Real temperature is negative 16.8 Celsius degrees. What the heck again? Negative value? Not the same as positive values? Let's enter this 0x5558 in Python. It gives us 65368. This is definitely not a temperature value, so how do we get negative 168 from 0x5558? Okay, this is too much to learn for today. I'll just skip it and give you a function. From Stack Overflow, it says if value is greater than or equal to 0x8000, then value equals value minus 0x10,000. And let's test it with 0f58. So 0f58 is greater than 0x8000, true. So 0x58 minus 0x10,000 is minus 168. Exactly what we want. This is for negative temperature value computation with the signed two's complement hexadecimal values. This is more of computer science basics than our mission today. But now you get it. You should know how to convert values you get from the sensor, no matter if it's positive or negative. Okay, it's a long way. Let's get back to our code and pick up where we left off. We were running this rr.registers. It returns an array with a value 243. This is actually just the decimal form of 0x000x-f3. pymodbus has done the conversion for us, and now we can just return this rr.register 0 divided by 10, and we get the real temperature this sensor gives us. Of course, for negative values, you will need to do the calculation of comparing and then minus that 0x10,000 we talked about just now. So this is our Python code to read the temperature sensor. Once you know how to put each value to its right position, it's pretty straightforward. When you buy a sensor like this, it usually supports not only temperature but also humidity. And it might give you another example in the datasheet. Now you can see the right text is PRC register 40,002 and the start address is 0001, which means you just add 1 to the start address when you call read holding register, which means RR equals client.read holding registers 111. Also, if you need to read both temperature and humidity, you just still read from address 0, but you get 2 registers, which means RR equal client read holding register 0 to 1. Then you get both temperature and humidity together. If you have been following along this video, you should be able to read the temperature through Modbus RTU and the RS485 port now. In the next video, I will show you how to build a graphical user interface on this Chipsee panel PC to display real-time data we got from the sensor with React.js and Python. If you want to learn more about how to use these electronic devices, don't forget to subscribe to this YouTube channel. Thanks for watching. See you next time.